Today we are going to talk on a new topic called network scheduling. Network scheduling. The theory part and all you have to learn from the text. These are normally any project can be managed if it can be represented using a network. There are two methods in which you can solve used in network scheduling. There is CPM and PERT. Okay. First we'll deal with CPM. Now these are both used for project management. They are both used for project management. Project management. Now, every project will have activities associated with it. Like building a bridge, there will be many activities. For that, first activity will be acquiring raw materials like cement, steel. All those are activities. Once the steel is obtained, you get the labor. Then use all these activities together and then start building the pillar. That is one activity. After building the pillars, you go to the next step. So there are many activities. Now, each activity will have durations associated with it. Some duration associated with the time taken to do certain activity. It may be in hours or days or weeks or months, etc. Okay. Then there will be a precedence relation. Precedence relationship between the activities. Precedence relationship between the activities. What is this precedence relationship between the activities? It means, for example, the pillar can be built only if you mix certain amount of concrete along with certain metal. Only after that mixing process or acquiring those and then mixing, then you can start building the pillar. So, for activity to start, a previous activity should finish. Once this activity is over, you can start the next activity. So there is a flow of events. Okay, that is called the precedence relationship. So these are the inputs for a network in critical path method. So each project will have activities, duration and precedence relationship. This can be used in critical path method. So we will first do one small example here. You have activities. Then there is preceding activity. Okay. Let this be A, B, C, D, E, F, G, H, I, J and K. This many activities. Now it has got certain preceding activities. A and B does not have any preceding activities. Now C and D has got activity A. E and F has got activity B. G, H, I has got activities D and E. J has got activity C, G and K has got activity F, I. Just draw a line to show which one is which. Okay. This means A and B can directly start. It does not have to wait for any activity to finish so that it can start. C and D can only start after A finishes. E and F can start only after B finishes. G, H and I can start only after both D and E finishes. If D and E finishes, all these three activities can start simultaneously. J and K can start only after J can start only after C and G finishes, and K can start only after F and I finishes. Now to represent this in the form of a network. So there will be, we are using the form called activity on arc method. You're going to place the activity on the arc. There will be nodes and arcs that connects the node. So let us start with the first one. You number it sequentially. So this is number 1. Now A and B can start simultaneously. That means these A and B can start together simultaneously. This is A and this is B. Okay. We can number this again as 2. Okay, so this is one event. Our first event is A and B starting together. On reaching 2, activity A finishes its job. Okay. On reaching 3, activity B finishes its job. Now we have C and D. We can start only after A finishes. So it can start at this point. C ക്കും D ക്കും A തീർന്ന ശേഷം മാത്രമാണ് start ചെയ്യാൻ പറ്റുള്ളൂ. So it can start at this point. So we will do C here and then D here. Okay. Let this be like this. 4 and 5. Okay. So these are over. Now E and F can start after B finishes. B finishes ivideyanu. So E and F can start. So write E, we don't know where it is going to be. E and F. This is 6. Okay. Let's see. We don't know whether it's going to end up here. Let's see. Now G can start where D and E finishes. D and E finishes at this point. Okay. So G can start here. G. Now H can start where D and E finishes. So H is here. D and E finishes at this end point. So this is H here. Then I can start where D and E finishes. Let I be here. We will do it here. Okay. We'll see how it works. I finishes here. Now J starts where C and G finishes. C and G finishes here. So we are going to do J. F and I finishes here, so K starts here. So everything together finishes at a point. This is 7. You have to put arrow marks for all this. Should be having arrow marks. Okay. So these are the activity. Now along with the activities, they sometimes will specify the time taken. So you can write that time taken here, let it be 15. So activity A will take 15 units of time or days or anything, measurement to finish to reach to event 2. B will take some amount of time to reach 3, let it be 20. Okay. So you can place the activity as well as the duration on this graph. So this is how you draw a network first. You will be given an activity list and a preceding activity. Based on that you draw. But when you draw, you have to have nodes which will be numbered sequentially. You can't just number unordered way. You have to go only in an orderly manner. And then you place the arcs, activity name on top of the arcs and the duration also. Okay. And place arrow marks. Okay, you can't have any dangling events. You can't have any dangling events. That does not go to the finish point. You can't have one like this where there is no connection. Imagine there is no connection between 6 and 7. 6 is hanging and 7 here. So you can't have like that. One start point and one end point you should have. There can't be any dangling events. These are called merge events. Merge events. So you can see many activities coming and merging into one point. This is called a burst event, where this shows a beginning or the initiation of more than one activity. Initiation of more than one activity. So you had two: burst event and merge event. Merge event. Merge is where two or more activities converge at one event. It is called a merge event. Burst event is, it indicates the initiation or starting of two or more events from a point. Then you can have dummy or redundant event. You can have dummy or redundant event. Dummy or redundant activity. For example, there is one node here, there's another node here. One activity goes from this first node to the second node. There's again another activity going from the first to the second node only. So you can't write like this. You can't draw like this. So what you do is you use a dummy event where it goes to this one and then from here it goes to the second one. So you can represent like this. This is a dummy activity. That is, when there are two or more parallel activities. Two or more parallel activities having the same head and tail events. This is a head and this is a tail. Starts from the head, ends at the tail. So if you have two activities starting from the same head and ending at the same tail, we call that parallel events. So to avoid confusion, you use a dummy activity where the second one can be used to represent it. This one won't have any duration associated with it. That duration will be represented here. The activity name and the duration will be represented here. This is just existing there to show a neat representation in the network.